Okay, so good morning to one and all. So this is today is the practical lecture. So we will conduct today one practical, that is experiment. So we will conduct the experiment, that is Scott connection. Okay, so what is meant by Scott connection? So A division people already know what is the Scott connection. For B division student, we will discuss that in a theory also. Okay, but all of you understand what is the Scott connection, how the connection it can be done. So Scott connection, it is nothing but what is meant by Scott connection. What is the necessity of Scott connection? We will discuss in the theory. For A and B, this is one of the practical, that is Scott connection of three-phase transformer. Okay, three-phase transformer is a Scott connection, right? See, see, title of this experiment, that is experiment number 8, that is Scott connection of three-phase transformer. Scott connection of three-phase transformer. So what is meant by Scott connection and how the Scott connection it can be done, so that we will discuss in this today's practical, and also we will perform this practical by physically, how it will be works, as well as how the connection it can be done and what is the output of that experiment. Okay, right? So title of this experiment, it is nothing but Scott connection of three-phase transformer. So we will discuss regarding aim of this experiment is that the Scott connection of three-phase transformer. So by what is meant by Scott connection, first of all I will tell. The Scott connection, it is nothing but the it is called as a three-phase to two-phase conversion, or two-phase to three-phase conversion, that means vice versa. All of you understood? Scott connection, it is nothing but if we available supply, it is in the form of three-phase, and if we want to convert this three-phase to two-phase, then these types of connection it is important, right? So Scott connection, it is used for three-phase to two-phase conversion, as well as vice versa, that means two-phase to three-phase conversion also. But do you know that our generation, it is always it is in the form of three-phase. So there is a no generation in the form of two-phase. So we are generally not using two-phase to three-phase conversion. We are using three-phase to two-phase conversion. Okay, right? No, that means if our load it is in the form of two-phase, our load it is in the form of two-phase, and the supply availability it is in the form of a three-phase. So for that purpose, we use a Scott connection, that means three-phase to two-phase conversion. Now how it will be converted, we will understood by performing experiment also. See, the apparatus required for doing this connection or performing this Scott connection, it is one type of connection of three-phase transformer. In that we are using a two single-phase transformer. Okay. Again, three-phase transformer, it can be made either by combining three single-phase transformer, or by combining core and magnetic of a that means transformer, we make a one three-phase transformer. Okay, so see, if there are three-phase bank is there, that means single-phase bank is there, and by using a three single-phase transformer, if we form a one three-phase transformer, so like that, for conversion of three-phase to two-phase, we required a two transformer. In that, one transformer it is called as main transformer, and the second transformer it is called as teaser transformer. One transformer it is called as main transformer, one transformer it is called as teaser transformer, and these two transformer, or by using these two transformer, we are converting three-phase to two-phase supply, or we are able to convert two-phase to three-phase also. But our generation it is in the form of only three-phase, So we are not using 2-phase to 3-phase conversion, we are using only 3-phase to 2-phase conversion. Okay, see, for performing this experiment, the apparatus required is nothing but voltmeter to measurement of output voltage or to measurement of secondary side voltage of the these two single phase transformer, that is two quantity of voltmeter. Then to measurement of 3-phase voltage we required a range up to 440, that means we are using here 0 to 600 volt voltmeter, one quantity. Next one, to measure the current flowing from secondary madhun flownaara current, because we are providing load, that is 2-phase load. So to measure that current we are using a 2 ammeter having a range of 0 to 10. Again we required one of the ammeter, that means 3 quantity of ammeter, so it is having a 0 to 5 ampere range. Suppose we want to measure it is in the each phase current, then 3-phase Varac, that means one of the auto transformer it is required, 3-phase Varac it is required, because we are applying input to that of transformer by using an auto transformer. That means a variable input it can be applied, and we are reaching at some value and we are taking a reading. Now single phase transformer with tapping, that means single phase transformer with there are some taps are provided, 1 kV rating, and single phase transformer again there are some of the tappings it can be provided. Okay, म्हणजे tap provide असलेले त्याला connection करता येणार. So one transformer required tapping 50%, one transformer required tapping 86%. So I think A division people know how the 86% winding it can be choose. We have derived one derivation related to that in case of Scott connection, so that the teaser transformer primary winding turns it is nothing but 86.6%, and the main transformer it is centrally tapped, so it can be divided into 50% turns and 50% turns, so that 50% tapping is required, 86.6% tapping it can be required. Right, see the schematic diagram for that same, how this experiment it can be done. In that see this transformer, this is one of the transformer, that is single phase transformer. So this transformer it is called as teaser transformer, and this transformer it is nothing but a main transformer. This is the main transformer. See, this is the single phase transformer primary winding, this one is the secondary winding of the first transformer, this one is the primary winding of the main transformer, and again here it is secondary winding of the main transformer. Okay, now here it is 3-phase supply it can be given to that of these two transformer. So for doing the connection, that is Scott connection, we required a 2 single phase transformer, 2 single phase transformer लागतायत. So one transformer it is called as a teaser transformer, second one transformer it is called as a main transformer. So main transformer it is centrally tapped. So see the winding, primary winding of the main transformer it is centrally tapped. Okay, see the main transformer it is nothing but the primary winding of the main transformer it is tapped at 50%, that means it is centrally tapped, and we have derived one derivation, the primary winding of the teaser transformer, how much primary winding it can be used for teaser transformer, it is nothing but it is equals to 86.6%. Okay, so we have derived one derivation related to that. This derivation we will derive while discussing the theory for the B division student. See these two transformer, by using these two transformer we are converting this 3-phase supply to the 2-phase supply. So this, see here it is a 2-phase, one single phase load, again here it is one another one single phase load. केला होता call. One single phase load, that means there is a 2-phase load on the secondary of these two transformer. या 2 ट्रान्सफॉर्मरच्या सेकंडरीला किती लोड आहे, two phase load. On the primary of this transformer, there is a three phase supply. See here, this is the three phase supply. So that means we are converting a three phase to two phase. So suppose this is the R phase, this one is the Y phase, this one is the B phase, and here it is neutral. Right? Here it is neutral. So we are converting a three phase to two phase, three phase to two phase. So for that connection, we required a two single phase transformer. So two single phase transformer in the sense of we are using one transformer, it is nothing but main transformer. Second transformer, it is nothing but a teaser transformer. Winding of the main transformer, it is centrally tapped. Winding of the main transformer, it is centrally tapped. And the winding of the teaser transformer, that is primary winding of the teaser transformer, it is 86.6%. So this is the standard value. So we have already derived this one. So see, on the secondary of this transformer, we are connecting a load. Secondary side la load connect kar do. This is one phase load and this is another one phase load. That means a two phase load. So that we can call it as a two phase conversion. Getting what I am telling? That means we are converting three phase to two phase. Input side, how much terminal or how much phases is there? On the input side, how much phases or how much terminal is there? Yes, give me reply fast. On the input side, there are three phases, and on the output side, we are getting a two phase output. So here it is one single phase, here it is one single phase. If we do this neutral common, that means we are getting a two phase output, right? We are getting a two phase output. So why this connection it is necessary? So sometimes if we know the furnace load, or it may be sometimes one of the heating equipment load. So generally this load, it is nothing but it is in the form of two phase, right? So to provide the supply to that of two phase load from three phase line, such a connection it can be used, right? Or I think you people know generally the welding transformer, it is in the form of two phase. So welding transformer, or it is nothing but furnace type of load, it is in the form of two phase. So to give a supply to that of two phase load, we required a three phase to two phase conversion, right? We required a two phase to three phase to two phase conversion. So by connecting two single phase transformer in the Scott manner, that means in the Scott, so two transformer, it can be connected in Scott manner or it may be Scott fashion. So we convert three phase to two phase. Similarly, vice versa, it can be also possible. That means we are able to convert two phase to three phase also. Two phase pasun three phase पर्यंत पण conversion करू शकतो, right? We are able to convert two phase to three phase, but our country, there is no generation in the two phase supply. So there is no generation in the form of two phase. So we are not in using two phase to three phase conversion. Generally, we are using three phase to two phase conversion, right? Getting what is the use of this Scott connection, or why it is necessary? All of you getting? Yes, give me reply. Hello.
Yes, sir.
Okay. See, simple. Two single phase transformer it is required. In that, two single phase transformer, one transformer it is centrally tapped, and another one transformer it is having a primary number of turns is nothing but 86.6%. Primary number of turns, it is 86.6%. So this turns, it is derived, or there is a proof for that. We have already derived this one for A division student. For B division, we will discuss it in the theory. Now see, why it is called as teaser. So this connection of the primary, it is like as a T shape. Okay, this connection of a primary, it is like as a T shape. So we are called as a Scott connection or T connection. Call it as a, so this will be formed as a opposite T. Baga, itun this connection primary of these two single phase transformer, it will be like as a T type connection, so that we can call it as a Scott connection, or it may be T type connection, right? Getting, see here how we are doing. So see the primary winding, that means R phase, Y phase and B phase. So there are both the primary winding of the two transformer, it can be connected. On the secondary side there is a load connected, that means on the secondary side there is a two phase load. If we do the neutral common or the negative common, then we will get the directly two phase, or it is nothing but this is one of the single phase, this is one of the single phase, that means two phase load, right? See this one is the VARAC, then R phase of this VARAC, it can be connected to one terminal of the teaser transformer. Next terminal of the teaser transformer, it can be connected to 50% tapping, or do you know that this main transformer, it is centrally tapped. हा जो काय ट्रान्सफॉर्मर आहे तो सेंटरला काय केलेलं आहे, टॅप केलेलं आहे. ओके, सेंट्रली टॅप केलेलं आहे म्हणजे कनेक्शन साठी टर्मिनल. सो वी कॅन कॉल इट एज अ 50% टॅपिंग, राइट? वी कॅन कॉल इट एज अ 50% tapping, it can be used. 50% tapping, it can be used. Okay, now so this point, it can be connected to 50% tapping. At that situation, this primary number of turns, it can be divided into two part, right? याच्या काय प्रायमरी नंबर ऑफ टर्न्स असतील त्या किती पार्ट मध्ये डिवाइड होतील? हाऊ मच पार्ट? प्रायमरी वाइंडिंग ऑफ द टू मेन ट्रान्सफॉर्मर ची प्रायमरी वाइंडिंग इथं कनेक्शन केल्यामुळे इकडे किती राहतील? Suppose here it is a 50% turn on this side and 50% turns on this another side. So on this first 50% side we are connecting one Y phase, and another one 50% side we are connecting B phase, right? So like that a three phase it can be done, and these two transformer, it is used to convert it into two phase. The two phase मध्ये convert करण्यासाठी use करतो. So see on the secondary side of the transformer, there is one voltmeter, it can be connected to measure the induced voltage. There is one ammeter, it can be connected to measure the load current at the one phase, that is I2 of T, that means secondary current of the teaser transformer. Similarly, for the main transformer on the secondary side, it is used to measure the V2M. V2M is nothing but secondary voltage of the main transformer. I2M is nothing but secondary current of the main transformer, and load it can be connected. So it is nothing but it is used to two phase conversion. That means two phase output it can be obtained, right? All of you getting connection diagram? We want to do the connection same, and we want to perform the practical. All of you getting? Give me reply immediately.
Yes, sir.
Okay. Now we will discuss regarding procedure. Connect the circuit as shown in figure. Set a three-phase VARAC. Set a three-phase VARAC to that of initially at the 0. Switch on the power supply. Vary the supply voltage using auto transformer up to rated voltage, and then the reading of ammeter and voltmeter, it should be taken. Okay. After that, we are able to take the reading of ammeter and voltmeter by increasing the load also, and by at no load condition also. So this is the procedure of this experiment. Then observation table. All of you take screenshot of that observation table, because you want to write the value of current, value of then voltage of main transformer as well as teaser transformer, right? So at no load condition and at a no load condition, we want to take the reading. Okay, we want to take that reading. All of you take screenshot. Then model calculation. So I2M is equals to I2T. That means secondary current of the teaser transformer. It is nearly equal to secondary current of the main transformer. And similarly, V2 of T, it is equals to V2 of M. That means secondary voltage of teaser transformer, it is nearly equal to that of secondary voltage of main transformer. So this conclusion we will observe and by performing this experiment and calculate the value. If we know this value of secondary side, then calculate the value of primary side. That means calculate the primary current I1 of T, it is equals to formula for that 1.15 times the K into I2 of T, and I1 of M, that means main transformer primary current, it is equals to K times K times main transformer secondary current. And here all of you K it will be taken as a, that means transformation ratio, it is equals to 1 because we are using a 1 kVA rating transformer. दोन्ही सेम kVA rating चे transformer घेतोय. So V2 divided by V1 it is equals to K. So for that all of you take 1 kVA rating transformer, that is value of K is equals to 1. So this is the model calculation, and after that the result, the 3-phase to 2-phase conversion was verified. 3-phase to 2-phase conversion was verified. Okay, so this is result you want to write after performance of the practice. Okay, getting all of you, we will go for performance. Just give me reply. All of you getting this connection diagram and the theory, what is the Scott connection and how it can be used, or why it can be used? All of you getting?
Sir.
Yes, give me reply immediately.
Yes, sir.
Okay. Now we will go for performance. I will stop sharing. Okay, all of you pin my another number. I will show. I will on the camera of that number.
Meeting is being recorded.
Hello, all of you visible? All of you visible?
Yes, sir.
All of you pin that screen. That means you are able to visible clearly. Okay, see the equipment. This is the auto transformer, or this one is the barrack we are using. Now see, here it is input and output terminal of the barrack. So input side and output side. So this output side, it can be connected
to the transformer. Here it is another one switch we are using. That means we are using one of the MCB. Yes, we are using one of the MCB. Output of that MCB, it can be given to that of transformer. So see here we are using a two transformer. That means we are using a two single phase transformer having an kVA rating of 1 kVA. Okay, kVA rating of 1 kVA. One transformer, it will be act as a teaser transformer. Another one transformer, it will be act as a main transformer. We are using like that connection. See, again, the output of this transformer, it can be connected to a load. Transformer's output ja hai, it can be connected to a load. See, here it is three phase load. This one is the three phase load. We are using only two phases. That means two single phase load. That means our output, it is in the form of two phase. So that means it is the three phase to two phase conversion. So see, I am using R to N. It is nothing but one single phase load. I am using one Y to N. It is nothing but another one single phase load. At that situation, only red and yellow LED will be glow. We are not using the blue LED. That means we are not using the another one load. We are using only two phase load, right? That means we are converting three phase to two phase. See how the connection it can be done. Auto transformer. So see the output of the auto transformer output. I will do connection. So here at the input side, we are connecting a supply to that of auto transformer. So R phase, it is connected to R. Then here Y phase, it can be connected to here Y. Then B phase or B phase, it is connected to blue terminal. Right. So this is the input. Now see here, there is a output three terminal. Output three terminal. One is R, another one is the Y and B. See now the R terminal of the transformer, it can be connected here. Auto transformer's output आपण इथे panel ला घेतलेलं आहे बघा. So R, Y and B. So this input it can be taken. After that we will make the connection by using this MCB. See here it is R terminal. It can be connected to one transformer. Transformer, that is teaser transformer च्या one terminal, right? No, so this first one transformer, it is nothing but teaser transformer. This one transformer, it is nothing but main transformer. So as I have already explained the connection diagram, in that the R phase or R terminal, it can be connected to teaser terminal by selecting here. By selecting a number of turns is nothing but 86.6%. All of you visible this one? 86.6%.
Yes, sir.
Yes, sir.
By taking one terminal 86.16%, we are connecting these to the main transformer 50% winding. See here. See here it is 50% winding. At that main transformer 50% winding, we are connecting the next terminal of the teaser transformer. Okay. Now the main transformer, it is centrally tapped. So 50% turns it can be connected to B phase, and the 50% turns it can be connected to Y phase. See again I am taking the Y phase. This is the Y phase, and this Y phase it can be connected to that of 0 volt point. That means one common point to that of main transformer, and the 100% turn, that means this is first one 50% and this one is the next one 50%, and the B phase or B terminal, it can be connected to the 100% turns. That means next 50% turn. From here it is 50%, here it is 50%. That means main transformer, it is centrally tapped. Okay. So this is the condition while doing the Scott connection. So main transformer, it is centrally tapped. That means it is centrally tapped. And the teaser transformer, there is a derivation of teaser transformer. So teaser transformer having a number of turns it is nothing but root 3 by 2, root 3 divided by 2 to that of main transformer primary or TP, turns of the primary. Okay, so we are connecting it to the 86.6%. So this is the primary side connection. Now on the secondary side, so teaser transformer, secondary of the teaser transformer, it is connected to the one ammeter, एका terminal. Next terminal of the ammeter, it can be connected to the load. Ammeter चे next terminal load चे एका terminal ला connect केले. Then next terminal of the load, it can be connected to the transformer full winding. That means it is 100% connected. Right. Next, one voltmeter is required to measure the secondary induced EMF, so that across 0 and 100 we are connecting one of the voltmeter having a range 0 to 300. Right? No, 0 to 300. As we know that the voltage at the secondary side, because it will act as a single phase, so voltage it is near about 230. Now similar connection for the main transformer. One terminal, that is common terminal of the main transformer, it can be connected to one of the ammeter. It can be connected to one ammeter. Then next terminal of the ammeter, it can be connected to one terminal of the load. Load check ka terminal la connect kille, that is Y phase. Next terminal of the load, it can be connected. Next terminal of the load, it can be connected to 100% winding. That means 100% terminal of the main transformer. Main transformer चा 100% terminal ला connected. Again, to measure the secondary voltage of the main transformer, we are using here one voltmeter having an range 0 to 300. Right? See here it is 300 volt. We are using. So this one is the voltmeter V1 of teaser voltmeter used for teaser transformer. This is another one voltmeter used for the main transformer to measurement of secondary voltage. This is one of the ammeter. It is used to measure the current of teaser transformer. This one is the ammeter which is used to measure the current of the main transformer. And here it is load, it can be connected, that is two-phase load, it can be connected. And by varying this terminal, we are increasing the load also. Here it is load terminal, we are increasing the load also. Again, to measure the supply voltage, that means primary side, there is a three-phase, so that we are using one voltmeter having a range 600 to measure the supply voltage. See, this voltmeter, it can be connected at the output side. Here it is at the output side of the auto transformer. That means I want to measure only supply voltage. How much supply it can be given for measurement of V1 primary value supply voltage. I am using one of the voltmeter having a range 0 to 600. Okay, so this is a connection which is simple as per the circuit diagram. As per the circuit diagram, this connection, it can be simple. All of you getting this connection? Hello. All of you getting how the connection it can be done?
Yes, sir.
Okay, now we will perform the experiment. Now the connection already as per our circuit diagram. See here, R phase, it can be connected to that of teaser transformer one terminal la. Next terminal of the teaser transformer, it can be connected to the 50% tapping point. Y phase, it can be connected to that 50% winding. On the other side of tapping, there is a one B phase, it can be connected. So this is the primary side connection. And one voltmeter, it can be connected to measure the supply. Similarly, on the secondary side, for teaser transformer, one terminal of the teaser transformer, it can be connected to ammeter, one terminal. Next terminal of the ammeter, it can be connected to load, one terminal. Next terminal of the load, it can be connected to transformer, 100% terminal. And one voltmeter, it can be connected across that to measure the secondary voltage. Similarly, the secondary connection of the main transformer, one terminal of this secondary of the main transformer, it can be connected to emitter, one terminal. Next terminal of the emitter, it can be connected to load. Again, next terminal of the load, it can be connected to transformer, 100% terminal. And then across secondary, there is one of the voltmeter, it can be connected to measure the induced EMF or the secondary voltage, that is V2M. Okay. Okay. Now we will perform. Is there any doubt in the connection? Yes, anyone? Is there any doubt? Hello? Give me reply immediately. Don't waste the time. Okay. Now, initially, we will set the auto transformer at 0 value by gradually varying the value of this auto transformer. That means we are gradually applying the supply voltage to the rated value or somewhat less than value, and we are taking the reading at no load condition, and we are taking the reading at no load condition. Right? See, I will switch on this MCB. After that, my auto transformer is at 0 position. Then I will switch on this MCB. So for protection purpose, we are using here two MCBs here. Okay, I will switch on. Now, see here. At this situation, there is a voltage, input voltage given to that of transformer. It is nothing but 0, right? What is the value? 0, no?
Yes, sir.
Okay. Now I am gradually varying the auto transformer. I am gradually varying the auto transformer. That means I am giving the supply voltage to that of transformer. Right? See, I am varying this auto transformer. At that situation, voltmeter, it will be show some of the reading. Right? That means we are providing some supply voltage. See, I am again varying the voltage at the input side. It will be start increasing. Right? This thing? Hello?
Yes, sir.
Input voltage. Okay. See, we are increasing the input voltage. At that situation, see, on the load side, there is a 2 LED, it will be glow. That means we are providing 3 phase to 2 phase. That means we are connecting 2 phase load, only R phase and Y phase, because we are connecting only R and Y. So that R phase, it will be enabled, Y phase, it will be enabled. That means we are converting this 3 phase to 2 phase. जे 3 phase conversion होत, 3 phase load होता, त्याचं conversion आपण 2 phase मध्ये. Similarly, at that same time, the voltage induced at the secondary side, or the voltage at the secondary side of the teaser transformer and main transformer, it is also shown. See, this voltage, it can be shown somewhat value, it is nothing but 112. This value, it is nothing but again it is 110. See, here it is V2 of teaser transformer. This one is the V2 of main transformer. Kiti value hai? Can anyone read? What is the value? Hello? What is the value of teaser transformer at the secondary side? किती value आहे दिसते का? Read the connection. I have connected it to how much? How much? Yes. Okay. See, it is 112. I have connected it to 300. So multiply by 2. Multiply by 2. That means 224. Right? Similarly, here it is an also 224. 4, like that. That means the two side value V2 of t and the V3 of t, it is nearly equal. It is nearly equal. Similarly, at the no load condition, there is also some flux, some current distortion, or it may be there is some current, it should be present at no load condition. See, here it is reading, as I have connected it to 10. So in between 0 to 2, or here it is one line, and 1 to 2, there is again one division. That means here it is 1, 1.5 and 2. So it will show near about 1 ampere. So this is the 10 ampere current. Again, this will also show some of the reading, but this voltmeter I have used for high range. It is nothing but 20. This ammeter, it can be connected near about 20 ampere range. So it will shows very little deflections, right? See, at that situation, the load on the transformer, it is 0. Whether there is a load, it can be put at just only secondary circuit, it can be closed by using a load. But I have not given a one load. Load दिलाय का याच्यामध्ये?
No, sir.
Now I will vary the auto transformer. I will vary the auto transformer and gives near about how much? Near about 300 volt voltage, right? So see here, I will give 300. I am again varying. That means we will see the little fluctuation. Transformer 140. Okay, what is the reading now? Okay, we will do 160. Okay, see, we are giving input voltage 160. That means for 300 scale, it is showing 160. So multiply by 2. कितनी ले? कितनी ले?
320.
320. So that means we are giving a supply. We are giving only 300, not increasing more. Okay. See, here it is 120 and here it is 140. Right now 140 into 2, that means we are giving supply voltage 280. Okay. Now see, at that situation, here is output at R phase, output at Y phase, right? Output at R phase, output at Y phase. At that situation, the secondary voltage of the teaser transformer, see, read the value. Secondary voltage of the teaser transformer किती आहे? 148 into 2, right? No, here it is 148 into 2. It is nothing but 280. 140, not 140, 148. 2, 4, 6, 8 and 10. That means 148 into 2. 296. Right?
Yes,
So
sir.
all of you take reading. V2 of T, it is equals to 296. Similarly, V2 of PM, that means secondary voltage of the main transformer, it is also equal. That means it is nearly equal, or it is nothing but it is equal. So it is also 296, right? Right. Now, at this condition, the current, it is near about current, it is near about 1 ampere, and similarly for teaser transformer it is equals to 1 ampere. Now I will put the load. I will put the load, that means on this secondary side 2 phases I will on the load, that means it will show the current deflection. Okay, I will put it one load, that means I have on one load, again I will on another one load. Okay, second load I will put another one load, third, right? Okay, I have given load on the secondary of the transformer, that means on both side, that is both phases. That means teaser transformer output side and the main transformer output side. So see, at that situation, take the reading. At that situation, all of you take the reading. So supply voltage, it will be same. We have given already 140. So 140 into 2, it is nothing but 280. There is no change in the input supply. Whether it is change in the input supply? सप्लाय व्होल्टेज मध्ये काही चेंज आहे का? Yes, there is no change in the supply voltage. See, at that situation, the voltage of the teaser transformer, that is secondary voltage of the teaser transformer, it will be reduced. See, voltage of the teaser transformer, it will be reduced. What is the value? किती value है? Anyone?
140.
140 or 138 into multiply by 2, na? It is connected to 300. So 138 into 2, right? 276. Similarly, here is also 138 into 2. That means 276. Again, see, we have increased the output current or load. That means current, it is increases. So current, it will be shown by, this is the main transformer current. This is the teaser transformer current. So we will take teaser transformer current. Here it is reading, it can be given, or here it is on the load side. There is a, it will show also the value of current. See here, A phase. A phase is nothing but R phase current. What is the value? 3.5. Right now. And again for Y phase, it is also near about 3.5. So all of you take I2 of T, it is equals to 2.5, and then Im of T, it is equals to 2.5. Right. So take the reading. I will switch on. Okay. So what is the conclusion? What is the conclusion? We have already shown the model calculation in that given two equation, that is secondary voltage of the main transformer, it is equals to the secondary voltage of the teaser transformer, that I have already shown while discussing regarding PPT. So V2 of M is equals to V2 of T, right? No, बघितले ना आपण? Hello.
Yes, sir.
And similarly, I2 of T, it is equals to I2 of M. I2 of T, it is equals to I2 of M. Secondary current of the teaser transformer, it is nearly equal to the secondary current of the main transformer, right? So after that, you will calculate the value of I1 of T and calculate the value of I1 of M, right? That means primary current of the teaser transformer and the primary current of the main transformer you calculate. Okay, so formula is also given. I1 of M, it is equals to K into I1 of M, it is equals to K into I2 of M, and I1 of T, it is equals to K 1.15 into K into I2 of T, right? Yes, getting? Hello?
Yes, sir.
Okay. Is there any doubt? All of you understood?
Hello. Getting no?
Yes, sir.
Yes, sir.
Is there any doubt? Anyone? कोणाला काही डाऊट आहे याच्यामध्ये? I think for A division people there is no doubt for anyone. For B division student, we will discuss this same concept in theory also. That means you will better understand at that time, right? Getting?
Yes, sir.
Okay. So in this way, we will conclude this today's practical, and we will stop here. Thank you. Just 1 minute.